Okay, so I'm sure you have all got your own methods for solving simultaneous equations, right? We've just seen solving simultaneous equations with the last question, the one where we're doing vector equations of lines. However, this one specifically asks using matrices. So if you use any other method than a matrix method, you will not get the marks, right? Simple as that. Okay, so any ideas for how we could go about doing this?
You can put like in a matrix and then you can like an operation on one line to like isolate the variable.
Okay.
I can't remember.
Okay, that's fine. So let's break it down then. How could I convert this, which are basically just two equations at the moment, into a matrix form? Any ideas?
First one
Mm-hmm.
is 4 minus 2 and then a matrix.
Yep.
And then the other one is minus 3 and minus 8.
Great. So that's one matrix. What goes here?
X, Y.
Good. My variables. And that's got to be equal to?
12 minus 28.
Great. So can you see where all those numbers come from? Right? Coefficients, that's my coefficient matrix. My vector of unknowns, x and y. And my vector of known values. Okay? Now if you're kind of sitting there thinking, okay, I can see where the numbers come from, but why are these two things the same? Think about your matrix operations. Literally multiply those two things out, right? So 4 times x minus 2 times y. 4x minus 2y. That's got to be equal to 12, right? And negative 3 times x minus 8 times y, negative 3x minus 8y is negative 28. So it is the same thing. Okay, it's equal to the same thing. I'm just writing it as a matrix representation. So now I've written this, clearly, what do I want to find?
X and Y.
Good, I want to find x and y. So what I really want, the final line, is x and y is equal to numbers, right? So I want a vector here. So how could I do that? How could I rearrange this equation so I just get x and y on its own?
I mean, put on the other side, but I don't know if you can do that with matrices.
Put what on the other side? No, go on.
You put those values, but
That
I remember
matrix.
doing that on matrices.
No, absolutely. No, you're right. So that matrix there, let's give it a name. I'm just going to call it. Exactly. I'm going to call that A, right? So I want to get rid of that from the left-hand side. Now, ordinarily, if I was solving an equation like this, I don't know, something like 6a is equal to 12, you'd say, okay, divide both sides by 6. Division of matrices doesn't happen. Division of matrices doesn't make sense. However, what I could do instead is multiply both sides by the inverse, because multiplying by the inverse is the same as dividing. Okay? So if I think about A, so here I'll put it on the right hand side. So A is my 4, negative 2, negative 3, negative 8. I need to think about what is the inverse of A. Now, fortunately for you, that equation is in the formula book. Okay? So finding the inverse of a 2 by 2 matrix, it is in the formula book, but it's not hard. So first of all, I need to do 1 divided by the determinant of this matrix. What's the determinant of this matrix here? Not quite.
Minus 32 minus plus 6.
Okay, so minus 6. So what did you say? Minus
38.
38? Yeah, that's fine.
I don't know where it's moving from.
Yeah, no, that's fine. I can't remember what you said either. But yeah, negative 38 is the answer there. Because you have 4 times negative 8, that's negative 32, minus negative 2 times negative 3, that's positive 6.
Yeah.
So you've got to take away a positive 6, which is the same as taking away 6.
Plus minus is minus.
Let me write it down in case you're thinking. So 4 times negative 8 is negative 32, minus the negative 2 times negative 3,
Yeah.
that's a positive 6.
Yeah.
So negative 32 take away 6.
Positive 6.
Yep, but you're taking it away.
Yeah.
You see?
Yeah.
Yeah. So actually it might make sense there because it's a common mistake which people make. Write it down.
Yeah.
Yeah. write it down in full. Okay, so that's the determinant, so it's 1 divided by the determinant. Now what do I have to do to this matrix when I'm taking the inverse?
In the 2 by 2, you like swap the numbers around on the
Good, what numbers do I swap?
bottom left, top right.
Other way round.
Oh, the others, I guess.
Yeah, top left, bottom right. Okay, so this leading diagonal. So -8 and 4 swap places.
Okay.
But I do something here as well.
Signs and the signs.
Yeah. What do I do something here? The signs, right?
Yeah.
So I change the signs of these ones, right? So that becomes 3, that becomes 2.
I missed it.
Yeah? Now don't worry, because that formula is in the formula book. Admittedly, it's in terms of like A, B, C's and D's. So if I have A, B, C and D, it will tell you where A inverse ends up looking like. So you can always keep that in the back of your mind. Now just remember as well, just while we're here talking about inverses, I may also ask you as well to find the inverse of a 3 by 3 matrix. Remember looking at that? Yep. So there is an inverse of a 3 by 3 matrix. We're not going to do an example like this. We can do an example as future revision if you want. But for the moment, let's just stick with answering this question. So what that means then is that I'm going to multiply both sides by A inverse. So if I multiply both sides by A inverse, well, A inverse times A is just the identity matrix. So I can just leave that as xy. Okay? On the right-hand side, though, I'm going to have to take this A inverse and multiply it by 12, -28. Now, the order really matters. Okay, so if I'm doing this, I always need to put the thing I'm multiplying by at the front. Okay, always at the front. So I'm going to take this -1/38 of this matrix, my -8, 2, 3, and 4, and that all gets multiplied with my 12 and -28.
Oh.
So always, always, always put the thing you're multiplying by at the front. Okay, does that make sense so far? Yeah? Now all I need to do is just do my matrix multiplication, get that multiplied out. Now the reason why I've left the -1/38 at the front is because I really don't fancy multiplying fractions with integers. Okay, I'm just going to multiply these two things out and then do the -1/38 at the end, and hopefully it all falls out nicely. So let's give this a go. xy is equal to, I'm going to leave the -1/38. Okay, -8 times 12 is -96. 2 times -28 is -56. What's that? -96 minus
152.
Okay, I'm going to go with you then. -152. Maybe it might make sense if Chun, you've got a calculator. Just to keep in mind.
96 and 56, right?
Yeah, and take them away from each other.
That's 140 plus
Yeah,
12.
that's true. No, that's fine. Okay, so 3 times 12, that's 36. 4 times -28, that's 112. So I want to take, what did I say?
46.
36. 3 times 12. 36 minus 112.
That's 76 minus 76.
Yes, I agree. And then hopefully 38 goes into that. So if I multiply through by -38, let's see.
It works very well actually. It's like, it's 4, 2.
Yeah, okay. I agree with that.
What do you think it?
Yeah, just double check just to make sure we haven't made any mistakes. But the fact they come out nice is probably a good sign. So what we can literally say is that x is equal to 4 and y is equal to 2.